Hi all, welcome to this session where we are going to do a real-time credit card fraud detection build which has been done with IBM Bob. So here we basically see how Bob can install Confluent Kafka, develop and document the credit card fraud use case in near real time. So for that we basically need to understand the use case a little better. So what we are seeing is there's a big challenge in terms of the credit card frauds happening annually around the world. So there's a lot of money being lost that way. And one of the key issues is most of the processes are batch dependent. So there's a delay in detection of the fraud happening, and an average fraud amount of $190 is lost per transaction, and there are a lot of false positives as well. So those are some of the current challenges, and this solution basically helps us to track these frauds with a below 100 millisecond latency. So it's a real-time fraud detection, and we are seeing how IBM Bob could come up with some of the fraud detection patterns as well using Python code. We can do it with a 95% accuracy, and then we will see how some calculations could be done as to show what are the benefits based on some of the assumptions. And then coming to the technology stack, we are using the Confluent Kafka Community Edition. It is available on the Confluent website, so anyone can go and do a download. But the advantage with IBM Bob is it gives you all the steps that are required to do the deployment, so it becomes much faster. And then of course you could leverage for any kind of logical writing of your Python code. You could use Bob again, and all of this is on top of enterprise Linux. So here what you see on the in the picture on the right is basically a typical production grade environment involving Kafka data streaming for fraud detection. So you can get different kinds of real-time data from the enterprise, and then this could be basically processed, and you have different interfaces to which the detection of fraud could be managed. So coming to the system architecture here, so for here we have built everything on top of Red Hat Enterprise Linux. It's version 9.x. So here we are having a producer and a consumer for the payment. So the producer basically generates these transactions, and it has some amount of fraud transaction generation as well. And this logic is developed with IBM Bob. And we have the Kafka cluster in between. So basically, we have built a topic called the credit card transaction topic, and we have Zookeeper as well, which is used to run this service. And then we have the payment consumer, which basically detects the real-time fraud happening. And here we have those 7 patterns for analyzing the fraud based on the user profiling and doing a risk scoring on a scale of 0 to 1. So this is a little more deep dive into what exactly is the fraud detection intelligence involved. So basically there are certain patterns. So this is one of the ways of rule-based detection. So here the success rate is definitely much more higher. There are very few false positives, and the different patterns here, there are 7 criteria which is being used, and basically for each profile the scores add up, and based on that, if it touches reaches amount of 0.95, it is flagged as a fraud. And these are some of the results. So the producer produces the transactions as we see on the left, and then the consumer detection is on the right. And the Bob can also help you assess the business impact. So here it has made certain assumptions where it says if there are 1,000 transactions at around 15% fraud rate and an average fraud amount of $400, you could finally have an annual benefit of around 340K US dollars. So with that, we go into the GitHub link. So what you see here is the git ignore file that has been generated by Bob. So next it produces the transaction producer. So as you see, it is generating this logic in Python code. So it has already documented that. I had walked you through that earlier. So one of the key benefits of using IBM Bob is it ensures that the code that is generated is compliance in terms of all security vulnerabilities. It can adhere to, say, any of the credit card standards which the regulators would expect, and so on. So that's something which is built in, and you can always verify that when you develop the code, and it shows that as well when you document the code. And in case any customer requires a different kind of regulation, it can incorporate that as well. So here now it's producing the consumer code. So the consumer code basically addresses the fraud, detects them based on the 7 analysis criteria that we had been seeing earlier. So next it starts with building the documentation. So I had walked you through something like this earlier as well. So here it shows how the zookeeper can be set up, what are the prerequisites that are required, what are the dependencies that need to be installed for Java, and then how you install the Confluent Community Edition, create the topics, how do you install Python dependencies. It even documents the whole flow, for example, here. Then you see the documentation. It talks about the different kinds of frauds that that the code is developing in order to address those and flag those as fraudulent transaction. And then it also sets up some of the Kafka housekeeping scripts, and also it is ensuring that it has put in all the links to which it has referred. So in this way we see that it has generated all the required documentation, and it is also summarizing what all are the changes that have happened. Now we are going to see the demo script. We have the producer, which is running on the left hand side. This runs on top of the Kafka cluster, and to the right side we have the consumer script, which is basically going to identify for fraudulent transactions and flag the same. So we already seen the logic that is being used. So now we are going to run these scripts. So as you can see, it has started generating at the rate of 1 transaction every second on the left hand side. That's the producer. And since this is a real-time solution, we see that to the right we have the consumer evaluating each of the transactions and flagging it as a legitimate transaction, or it could also flag it as a fraudulent transaction. So it builds a base for each user based on which it decides to flag it. So I think we walked through some of the logic earlier as well. So here we see a fraudulent transaction. So let us just go back and look at what it is. So here it says it has detected a fraud, and it says that it is basically from a suspicious merchant, and it also gives the summarized fraud detection percentage. And similarly, there's one more from a location which is seems suspect. So in this way, it is able to flag all these transactions in real time, so that the bank or the credit card company can take appropriate action in real time. Thanks a lot for watching.